Okay, so first let's look at what the answers are supposed to be, at least according to them. Alright, so 81 should be E. 56% of people got that one right. 82 should be B. 69% of people got that right. 83 should be B. 61% got that right. 84 should be C. 58% got that one right. 85 should be B. 43% of people got that right. And 86 should be C. 55% of people got that one right. How'd y'all do?
Only got 2 that time.
You got 2 this time?
That's so hard.
You get me? No.
Oh no, I was confident. I got it.
Garrett, how'd you do? Bad. Yeah, some of the stuff has been a while. Okay, so let's see.
You're in a position acceleration velocity one
All right, so let's see. 81 says if g of x is an antiderivative for f of x, and g of 2 is -7, then g of 4 would be what? All right, so that means that to get g, you have to integrate f. So basically it means that f is the rate of change of g. If I would have to integrate f to get g, it means that f is the rate of change of g, or the derivative of g. So we talked about this on Saturday, and I know y'all weren't here Saturday, so I'm going to go over it again. When you want to find the total change in something, you would integrate.
That's the opposite.
Yes. A derivative tells you a rate of change. An integral will tell you the total amount that something has changed if you know its rate of change. So this is telling me that at 2, g had a value of -7. If I want to know the value that g would have at 4, I've got to figure out how much it changed between 2 and 4 and add that to this value. So I know that it's starting off with a value of -7. If I integrate from 2 to 4, the rate of change of g, this will tell me how much it changes between 2 and 4. So this is my starting value, this is the change in that value, and so if I total those together, it would tell me what value g would have at 4. So it would be, right now I'm all gun shy because I can't figure out why I can't get that one right that says it's E. Now I'm all worried. Okay, so let's look at the next one. A particle moves along a straight line with velocity given by, and then they give you this velocity formula. What's the acceleration at 3? So what's the relationship between velocity and acceleration?
I did like that little chart, but I think I did the order wrong. I did position, acceleration, velocity.
You did the order wrong.
Is it position, velocity, acceleration?
Yes. So we take the derivative of velocity, right? So if it's asking me the acceleration when t is 3, it's asking me to take the derivative of the velocity at 3. Those mean the same thing. And this is what I'm going to use because that's what I'm given is velocity.
Is the left side the integral and the right side the derivative?
with the little chart,
Yeah.
you've got position,
That's what helps.
velocity, and acceleration. And so to work your way down, you take a derivative. Down derivative, right? And then to work your way back up, you integrate. So I can do this in my calculator. You can calculate a numerical derivative. That's what we call this when you want it to plug a number into a derivative. It's called a numerical derivative. You can do that in your calculator from your calculator screen here. We press menu, and then we go to calculus, and we're doing the numerical derivative at a point. Our variable, I'll just leave x. The value where I want it to do it at is at 3. So I put 3. And then I just type my function in there. So what was it? 7 minus 1.01 to the negative. I'm using x instead of t. It really doesn't matter what variable you use. So 0.0545 or something like that. B. Alright, so I did menu, calculus, numerical derivative at a point. And you can tell, I mean, if you want to change the variable to t, it really doesn't matter. And then the value where we're wanting to do this at is at 3. And so then we would type in our little equation here. And we get 0.055.
Can you solve it by paper, or would that?
No, because we don't have a rule for, there is a rule, but it's, to me, it's just not necessary to learn it, but there's,
Yeah.
we don't have a rule for taking the derivative when the variable is in the exponent,
Okay.
unless the base is e, which it's not.
Okay.
You know, we learned how to do if it was base e, so this one would be b. They gave you this type of equation because they know that you won't know how to do it by hand, and so they're testing on here whether or not you can do this in the calculator. So that's one of the things, I mean, I'm supposed to teach you how to do things by hand and by the calculator, and they're going to test both. So, okay, we said skip 83 for now. We are going to learn how to do that, we just haven't yet. All right, 84. I think this exact problem might be on your take-home test, maybe. I don't remember. I think it might be though. So it says the graph of the derivative of a function is shown in the figure above. It has horizontal tangent lines at -1, 1, and 3. So they're just telling you that that's where those maxes and mins are. At which of the following values of x does f have a relative maximum? When you see that, that's asking you where does the derivative change from positive to negative. That's what makes a maximum, is for you to go from having a positive slope to having a negative slope. You'll have a maximum anywhere that happens. Positive derivative, negative derivative, positive slope, negative slope. What makes this one tricky is that this is the graph of the derivative. So what am I going to look at on this graph that will tell me the slopes of my function? Your y values. So basically this is asking me where do the y values change from positive to negative. And it only happens at one place, over here at 4, where I go from being above the x-axis to below. I think I gave y'all, like last semester, some little flashcards to put in your little folder that we haven't looked at in a long time. And some of this stuff is on those flashcards, like, so that you can start quizzing yourself over when it says relative maximum, what is it really asking me about? When it says relative minimum, when it says increasing, what am I supposed to do? Decreasing, what am I supposed to do?
Minimum, you wouldn't went from negative to positive.
Yes, so there would be a minimum on this graph at -2. Okay. This kind of goes back to what I was talking about on 81, I think. So this one says the table above gives values of a function and its derivative at selected values of x. If the derivative is continuous on the interval -4 to -1, what's the value of the integral from -4 to -1 of the derivative? Okay, so when we integrate the derivative,
Awesome.
Ugh. When we integrate the derivative, those two things cancel each other out. You take the derivative of an integral, it cancels it out. If you integrate a derivative, it cancels it out. So if I integrate the derivative of f, I just get f. Right? Because that's what an integral does, is it undoes a derivative. They're opposite operations. So then I plug in my bounds, right? I integrate my function here, so I integrate the derivative of f, I get f, and then I do f of negative 1 minus f of negative 4, which I can get from the table. F of negative 1, hello, is negative 1.5, and f of negative 4 is 0.75, so I get b.
I did it the opposite way. I just did like the derivative.
Yes.
And I just sent it
That's why they gave you that
minus.
line of the table, because really that line of the table is not necessary at all. But they gave it to you so that you would have to decide which values it was you were supposed to use.
Okay.
So that happens sometimes. They give you extra information that you don't need because they want to test whether or not you know what information you do need.
Okay, so I'm like, oh, this is easy.
Okay, last one, and then we'll call it quits for today. I kind of went a little long again. Okay, the table gives selected values of the velocity for the particle. Which of the following could be the graph of the position of the particle? So if these are all graphs of position and this table shows velocity, what are these values going to be on here on the position graphs? The velocity values are going to become, or they are, the slopes of the position graph. So this is saying that we're looking for a graph that at 0 has a slope of negative 1, and at 1 has a slope of positive 2, and at 2 has a slope of positive 3, and at 3 has a slope of 0, and at 4 has a slope of negative 4. Well, the only one that fits that is C. This one at 0 doesn't have negative slope. Neither does B. C and D at 0 both have negative slope. C and E do, D doesn't. But then at positive 1, the slope's supposed to be positive, and on this graph, the slope's not positive at positive 1. It looks like it's close to 0. So the only one that fits is this one. It's got negative slope, positive slope. When I get to 2 over here, the slope's even steeper. At 3, the slope would be 0. At 4, the slope's negative. So here you just had to recognize that velocities were going to be the slopes of your position graphs.